Welcome. Okay. So maybe I just talk a bit before we start, so maybe people come streaming in. Just to get a rough idea, what are your guys' level of understanding of this topic so far?
Zero.
Okay, what about like programming? So you guys at least have some like cursory knowledge of programming. Um, Maybe I may ask what kind of programming languages you're familiar with.
Java, a bit of C.
Okay, so most people like that. So today's one actually, we used PHP for the roundable sample because it's easy to write on PHP. It's a very easy language to get wrong. Um, yeah. So okay, now on you guys' level of Linux, how familiar are you? Yeah, basically it's using the shell, doing things from command line.
Most of them are year one students.
Okay, some on your end though.
Yeah, but they're just taking, let's say, CS 1010.
Okay,
So
yeah.
maybe not being familiar with the command line at all. Probably they do DIR or LS.
Okay.
That's about all.
Thinking.
It's okay because we'll be covering this, some of this. We'll be going through all these things with you all. So if at any point of time there are some steps which you all do not understand, just feel free to clarify them with us.
The thing is, you started broadcast, right?
Yes.
You press the start broadcasting, right?
Just check. Go to the bottom.
Okay, yes, broadcasting.
Go to the links thing over there. Just at the bottom.
What?
Just tell me the 4H.
Let me. The YouTube page or the event page?
Yeah, YouTube. W3. PT.
C capital U.
I will put that into the Slack.
Okay.
But if we do not speak directly into the mic, we'll,
Yeah, that's fine.
I think it's still
Seems to be
capturing, right?
picking up all right.
Your one's pretty strong.
And your mic is okay. You guys picking up my voice more.
Okay, so this. Where is your? I'm just gonna create a new one.
Which one?
The
The finance?
setting everything. Okay, save to console. Okay.
Then it's on the DPW.
You just wait for that. Is he joining? Yes.
I think it's just throwing some stuff.
Okay, so thank you guys for coming. Today we're going to talk about web security, but from an attacker's perspective. So usually if you go to a web security workshop or app development security workshop, you learn a lot more about the OWASP top 10. You learn a lot about how do you prevent things. But now I'm going to teach you how you're going to make the things happen. I'm going to break the things. Okay, so first off, who am we? I'm Eamon, and this is Kayan. I'm in year one. I'm in information security, and Kayan is in.
I'm a year 2 computer science student.
Okay, so first, this is an introduction to web security. It's hands-on, it's offensive, and we're going to get our hands dirty with a little code if you stay for the second session. And we want this to be a discussion kind of thing, so feel free to speak up. So first, the ground rules is that what you learn here and what we teach shouldn't be used on systems you do not have permission to attack. And also that we want you to know that the Singapore law prescribes quite hefty penalties on people who do break this law. It's actually called the Computer Misuse Act, and depends on the type of machine you break into. It can range up to 20 years and about 50,000 fine. So okay, today we're only gonna attack domain names with this pattern, this point domain name. So don't touch any other domain name. And also during the course of the lecture, we'll have access to certain shared resources. For example, I am going to give you guys a shell, and basically don't run anything that might stop anyone else from using it. I've put all the vectors I can. I might have missed something, so if you do find something, you can tell me and you can learn about it. Okay, so the rules of engagement again. There's only 3 URLs we're going to attack: ssh.sproink, web.sproink, and dvwa.sproink. Okay, so if you're all ready, let's get started. Okay, so today's agenda. For the first half of the workshop, we're gonna do preparation and environment setup, and we're gonna do a brief recap on the basic web concepts that you need to know. And also the meatier part of the session is we're gonna talk about the common web probabilities that you might encounter. You might find it in your apps. You might find it in other people's apps. Okay. And also in the second part, I'm going to teach you how do you automate your attacks and exploits with Python. And if we have time to continue, and some exotic bugs that we found and you might want to know of. Okay, so first, environment setup. I hope you've all got the 3 very, very easy things to install. It's Chrome, the edit this cookie Chrome extension, and the Secure Shell Chrome app. And the third one is optional if you don't have if you don't want to install the Chrome app. You can use one on your system like PuTTY, or you can use one if you're using a Mac. You can use it in your terminal. Okay, so everyone has the stuff ready, I suppose.
You guys installed the Chrome extension?
Can we have a show of hands who has installed
That's right.
those
You
extensions?
put it into your document, right?
Yeah.
Yeah, okay.
So the 2 of you, you are still installing it. The other 2 of you also still installing.
Okay, maybe just if you need help, just ask. It's really fast.
Okay, sure.
Yeah.
Sorry for the flickering.
Yeah, we'll try
No,
to figure
it's-
this out
it's-
while you
it's
install.
not- It happened a couple weeks ago too. It'll just do that. I don't know why.
Yes.
Stay.
Okay.
So if you ever have any issues, you can just let us know.
So you can install the Secure Shell
Yeah, actually, if you all don't have a shell application yet, the one that is more pressing that you all will need first is the Secure Shell Chrome app. Yeah, so just install that first. You go to the Chrome app store, extension for the Firefox.
Is he on Windows or? If you can't find it after installing it, you can type Chrome/apps and you'll get this page. In this case, Karan doesn't have it because he already has a Secure Shell, but it should appear right around here. So just let me know when you guys are ready to proceed.
Who's still installing the apps? I just have a show of hands.
Alright,
Okay, so everyone start?
yeah.
Okay.
Okay, so when you log in, yes, try to use this credential. So you start the app, and it should ask you for a username and a host name. So you use Orbital as a username and use ssh.spoink as the server.
Show me a screenshot.
Oh, there's a screenshot. Okay. Oh, this is not the one on the. Yep. So it should look like this here.
So yeah, so you can open up your secure shell application, the one that you just downloaded on Chrome, or your own shell, and then you just need to type in that SSH space orbital at.
No, it's not essentially. It's like you'll get like a username box and a hostname box. So you just type those in, and the password is we have the best passwords with the space.
It's a different interface.
Yes, it's different.
What did you use the shell?
Okay, maybe I just install and I walk you through because it's it's not the same. Okay, so I have this interface, right? So everyone's looking at this. You just put orbital at ssh.s like this. And so you just need to type this in. Okay. So once you're ready, you just press enter, and you'll get something that asking you to ask for, like, you want to connect. So just say yes, and you type in the password. We have the best passwords. So this is the password with the space and everything.
Or we can try the Chrome application. Yeah, sure.
Yeah, sure. Let's try that. What algorithm is that? Try going to
Maybe there's some setting where you select the algorithm, like box, some setting.
what do you want?
So not your screen.
Okay, so you install the Chrome Secure Shell. This one, not this one. This one.
Let's say yes.
You said it's Chrome.
So it shows that it's an extension.
Yeah, so just start that and get the interface. And you use this so you type orbital at.
Yeah.
So you'll see this interface, right? Which side one? You should see this interface, right? You just type orbital at ssh.sproink here, and it will automatically fill in these two parts for you. Okay, then you click enter. Okay, then you should get the password prompt, right?
No, I can continue connecting.
Oh yes, you say yes. You type yes, and then you get a password prompt. So the password is this thing here.
Try to connect.
Okay, so for like those who got past the password part, yeah, so for those who type in the password already, you'll get okay, let me just reconnect. So it should ask you for a desired username. This is because this is the thing that we're going to use to create your user accounts for the things we're going to do today. So for now, I'm just going to take maybe Kayan's name here.
I think it's taken.
Oh, it's taken. Okay, so I'm going to use my own name, Eamon. Yeah, mine is okay. And you should save these credentials. Just copy it, paste it in a text file somewhere, because we're going to use this for the web apps we're going to log into.
Sorry, I have trouble entering password.
It's just we have the best password.
I cannot type it.
No, it's not supposed to show anything. So it's like a password prompt. It doesn't show the extra tag.
You probably typed it in wrong. I typed it in many times wrong.
Yes. Yeah, so you can choose a username and that'll give you a kick you out. So you save this credentials somewhere in the text file.
File. Back would be the system. Anyone else need that?
So incidentally, right, this also gives you an account on the secure shell server. So once you have your username, you can use that to log in as well. Yep. So this is the shell that you're going to be using for the second part, not the first part. So everyone okay so far? Now make sure to save the password, because if you lose it, I can reset it, but it's not you can change it right now if you want to. So. But you have to use the same password for the web app.
Okay, we'll come to it. But
Yeah, you don't have to touch it now.
it's okay. You don't really have to change. But anyway, we'll run to that again.
Okay, so again, I have put protections in place so you can't spy on each other's processes. You shouldn't be able to do a fork bomb or anything. But if you find something else, let me know. I'll fix it, and then you get Mac credits. So I hope everyone can use a text editor of some kind, hopefully. Sublime is a textual interface. So if you're looking at this, right, there's no Sublime on this. So the easiest one to use would be Nano. So if I want to write a Python file that's like hello world, I'll just use Nano and like print hello. And you see at the bottom, I can't see it very well here, but look at the bottom, there is a bunch of kind of help stuff for you to use. So to write the file out, you do -O, and you'll say file name write, you save it, you can exit it, and you can run this file. So don't worry about this part is for later. So right now, we're gonna go on to actually talking about the basics of web. Okay, so maybe I just let the guy install. Are you almost done?
Yeah, that's
Okay.
I think you can continue.
Yeah. So this is just basically a recap. It's probably really easy. Everyone more or less knows this, but for the benefit of those who don't, I'll just go through it. Okay. So, first, the HTTP protocol is something that is the backbone of what we're going to look at. So at its heart, it's actually a text-based protocol. It's a very old protocol, and it has many improvements made upon it through the years. So today we're just going to look at the most basic form of it. So basically, the whole protocol involves a client making requests to a server for resources. So each time you get a web page, it gets a resource, a HTML resource, and it gets other resources like images. And sometimes these requests make changes on the server. For example, if you want to create an account, it makes a change to the database. And sometimes it doesn't, for example, you're just trying to retrieve information about an account. Okay, so this is how a handwritten HTTP request might look like. So if you don't know, right, you actually can write these requests by hand. You can grab a web page by hand if you want to. I'll show it to you on the shell. And it looks like this. So if I want to get maybe a simple web page, you don't have to follow along, this is just for your information. I'll just do it in the shell that I made just now. I can actually use something called netcat, which opens up a connection, a TCP connection between me and another server. And AT is the port that HTTP runs on. So if I do it like let's get the main page. I just get this, and you see that actually it is a valid HTTP request, and I get a web page back, which is the demo server index. Yeah. So let's break it down. Typically, you have the mandatory first line, which tells you what kind of method you want to use. So in this case, I'm using a get method, which says I want to retrieve a particular resource. The resource that you want to get, which probably is like a web page, could be an image, and the HTTP version. And the HTTP version is actually important in some ways because they determine whether you can have a persistent connection or non-persistent connection. So there are also other things in that request. In this case, I've included two. There are more, but in this case, I have a host name, which tells you what host you want to connect to. So if you go to like google.com, it might reside on the same server as, let's say, google.com.de, like near the German site. So someone who's visiting google.com will get it in English, and the one who visits the DE site will get it in German. And the way the server does this, it looks at the host name and it knows which one you actually want. And this allows you to have more than one domain name residing on the same server. So the other important thing to look at is the cookie. And the cookies basically is a way to give you persistence on a non-persistent protocol like HTTP. So now this should say response. So the response breakdown looks like this. So this is what the server sends back. From the first request, it actually goes to the server. The server now says, okay, this thing's a valid request, and I'm going to return a response. And this is just the headers. So right now you have the HTTP version again. You have a status code that says, okay, there is this thing is a valid resource, and I'm going to send it back to you. And it's in the body of the message that I didn't include. It's going to include the HTML page. Okay, so you have other headers as well, like your date header, you have the server header, and eventually you realize that these headers are all a goldmine of information because an attacker looks at you, he wants to figure out what kind of system you're running. So if you look at this, right, we ask you the question, what do you think can do with this information if you're an attacker? Anyone, just maybe throw out some ideas you have, anything that can just comes to mind.
You know what server you're using?
Yeah, so you know what server he's using, you know what server version, and you know what OS is using. So now if you look up, maybe you go on Google, you look at Apache 2.2.2 exploits, and then you run it against the server, and you know it will work because this is the server this is the final server version of Apache that's running, for example. Yeah. So when you're doing your web app, you should look into minimizing the amount of information that your application reveals, so you can lower the amount lower the chances of an attacker actually succeeding to compromise your server. So there are many methods supported by HTTP protocol, but the one that you're most interested in today is the get and the post methods. So like I said, the post methods, they usually have the side effect of making a change on the server. So okay, the next thing that's important is HTML. HTML is the basic building block of the web, I suppose. it allows you to prescribe the layout and the content of a web page. So it's essentially like a tree structure. It has a bunch of tags, there's attributes in it, properties, and this is an example. For example, like if you look at a div like that, it's not actually valid, but if you look at a div like that, right, that is HTML. Okay, anyone has any idea what the div does?
Divide the HTML elements into sections.
Okay, so in this case, right, what happens if you mouse over the thing? Sorry, what? Yeah, alert will be sent out. So alerts will be featuring quite prominently in this session. You'll find out later. Okay, so CSS it handles styling, representation of the page. So now, from your point of view, right? Okay, CSS, it just lets you style the page. So do you think there's any like problem if someone is able to specify any kind of CSS you want? Like for example, an attacker has control over a CSS script that your server will send along with its web page. Do you think there might be a problem?
I think they mess up your layout.
So you can mess up the layout, but that's not exactly malicious. That's just kind of mischievous, right? So maybe you can think about this, see if you can figure out a way to attack someone just by hijacking the CSS. Yeah, this is an open discussion, so you can talk if you want to. So the other thing is images, and even images are things that you don't really want to get wrong because, for example, you can, later on we'll talk about filtering as well. But in this case, this is an image tag. It's a valid image tag, and it's supposed to show an image, right? But in this case, what happens?
Use other images, other bad images.
So it doesn't work, and then there's an alert popping out. So again, there's this pattern of alerts. Okay, so JavaScript. JavaScript is I think the most interesting thing about the web because it allows you to provide the dynamic and interactive behavior for a web page. And yeah, so it can be linked or executed by placing it within script tags. And what also is interesting about JavaScript is that not only it allows you to tag the user through the browser and the kind of games we play where you have an alert, for example, that's just within the browser context. But what happens if you use JavaScript to get out of the browser and into the operating system and maybe into the Windows kernel? And that's really interesting, but I won't cover that here. Okay, so HTTP headers, like I said just now, there are common headers that reveal information. There are common headers that also affect the way the server behaves. Yeah. And now cookies is one very interesting header because HTTP by its design, right, is not a stateful protocol. It does not maintain any state about the user at all. So they have something called a cookie, which allows you to maintain kind of stateful session between the client and the server by having little pieces of information sent back and forth every time you make a request. Yeah. Okay, so now that's all for the recap. Pretty quick. Now for today, right, we'll be using a lot of Chrome because it's nice and easy and you already have it. So it's actually something that I use all the time for web analysis. And something that's important to know how to do is you have to know how to get the inspector up. So let me get it up. Let's say I have my website. Okay, so if you want to get the inspector up, right, you just right click, you click inspect here, and there's this little window that pops up. So you have a console that tells you, okay, what problems there are. You can write JavaScript in here as well. Oops. And you have this little elements tab that shows you the contents of the HTML page as well. Okay, so yeah. So from there, from that same inspector, right, you can look at the sources. In this case, there's nothing much here, but if I go to Google, it gives you a easy to look at list of the sources that Google uses. So you have images, for example. You have JavaScript files. I'll click on that. Yep. You have all these things that you can use to look at what the web server is doing. And also, I think the most important is you need to know about the network feature. So if you go and visit this site, right, you can see that there is a request that's made here. And look at it, you can see headers. So there you can see the request header here. And this is what the browser is actually sending. This part is what the browser is actually sending to the server as part of the whole request. And if you look here, there's also the response headers. And you can use this to look at what exactly is happening, or if you use it. So right now it's just nothing, it's just only one piece of traffic. But imagine when you're debugging a piece of JavaScript that's obfuscated, that you don't know what it does. So you just look at the network traffic and you figure out, okay, I don't know what this piece of code does, it's too convoluted to read, but I know what how it behaves because I can look at what request is making, I can look at what content it's sending, and in this case, it's actually much easier to look at it dynamically instead of reversing the JavaScript. Okay. So the other thing is the edit this cookie. It's a really useful tool. Yeah, so here, it should be a little cookie on the corner there. And right now I don't have any cookies, but we'll be using this during the Bound release part. So just make sure you know where the cookie button is. It's here. So when you need to use it, you don't get lost. Yep. Okay, so okay.
Okay. So thanks, Eamon. Yeah. So now I'll talk about the more. Let's come to the more exciting part about of our workshop. Okay. So let's begin off by talking about some common web vulnerabilities. Okay. So let's proceed to this website here. http://dvwa.spro.ink. Okay, go to this page on your browser, and guess what is the admin's password? No password? Let's give it a try. Which page? This one?
One that I opened this one.
It's okay, I'll open a new one. Okay, so admin without password. Nope, it's wrong. But what other passwords can you think of? Password. By the way, you know you can do this trick, right? If your friend types in a password but hasn't pressed enter, you can actually change the type of the field to text, and you can see your friend's password. So yeah, password is indeed the admin's password. Okay, so basically what we're trying to illustrate here. Okay, so default passwords are pretty common. Actually, what we could have done is just to do a Google search of the DVWA default password. Okay, and as you can see here, it tells you the default username is admin and the default password is password. Okay, things like that are not as uncommon as you think. Okay, for example, like many routers, they actually ship with default passwords because having to vary the default passwords for your customers is quite price intense. Okay, so also like root account on jailbroken iPhones. Okay, their default passwords are actually Alpine. So if you own a jailbroken iPhone and you connect to, for example, like some network where other attackers can see your SSH port, they can actually very easily connect into your device by using this default password, provided you did not change your the default password, which most people don't. Okay, and many
Bring the port back up.
Sorry?
No, no.
Supposed to be. Okay, my network is back.
Check the stream.
The stream is off.
Sorry?
You want to change it back to
All right.
screen share.
It's off?
Can you change it back to screen share? But it's not screen sharing anymore.
Okay. Okay, so okay, so most of you are here, I guess. Okay, so basically what we wanted to illustrate here is that, you know, even if we do not use the default passwords, many people actually use very weak or common passwords. For example, like in this password list here, the most common passwords are like password 123.056, 123.05678, blah, 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 QWERTY. Okay, so these passwords are easily guessable, and with a little bit of scripting later on, we'll be doing this if we have time. Okay, we can actually brute force, we can actually automate this brute forcing process to make it efficient for the attacker. So for example, we can make it smarter by using dictionaries. So we have a whole dictionary of common passwords, and then we just enumerate each of them on the password form here. And then essentially there will be some accounts which will get through. Okay, so what we are trying to emphasize here is that okay, what you can do as a developer, you can firstly, if you want to prevent this kind of brute forcing attacks, that means preventing someone from trying many times, Okay, you can temporarily lock an account after a threshold, or you can require CAPTCHAs. You can actually use this link. Google actually has a nice, it provides you with a CAPTCHA service. Okay, so you can use this link to get your own. Or you can enforce strong password policies. For example, like require your users to have alphanumeric passwords with upper and lower case, and symbols, and it must be a sufficient length. Okay, and maybe for example, like the NUS password policy, you require your users to change their passwords on a regular basis. Okay, so as a web developer, these are some of the common things that you can do to prevent brute forcing attacks like the ones that we will see in the next part of the workshop. Okay, so next we are going to be talking about SQL injection. Okay, so can all of you go to this page instead? You can just click on this link here of the website. Okay. So essentially, what does it do? If you try typing in 1, for example, it shows you the ID that you typed in. It shows you probably the first name of the user ID number 1 and the surname of user ID number 1. Okay, so essentially that's what it does. And right here, I'm going to introduce an important concept in security, which is called fuzzing. Okay, so fuzzing is a process where you provide invalid, unexpected, or random data to the inputs of a computer program. So it can be like a form or some other text field in your Java application, etc. Okay, so when you fuzz the inputs, essentially you are providing invalid stuff or unexpected stuff. Okay, stuff that the developer wasn't expecting. Okay, so in that, how do we apply that fuzzing in our case? Okay, so the user ID seems to be a number, right? But what if we submit something unexpected? Okay, let's try it out. So for example, let me just, if it's 1, it's working fine. But if I put a colon here, no, not a colon, quote, okay, it actually shows an error. Okay, so it says that you have an error in your SQL syntax, blah, blah, blah. Okay, so what's happening here? Okay, to find out what's happening here, we can actually look at the source code of the website. Okay, you can very easily access the source code of the page by clicking this link here. So at the bottom right-hand corner of the page, you can click this link here, and it will bring you to the actual PHP source of the page. Okay, so you can see here that this is essentially the part that is causing the error. Okay, I'm aware that most or some of you might not have SQL background on SQL, on using SQL statements and all that. So it's okay. I'll briefly like run through this with you. Okay, so what's happening on the page is this: if the user is submitting a request, okay, then we go into this loop. We go into this parenthesis, and then we just ID equals to the request ID. This part is not very important, but this is the important part, okay, where we construct the SQL query that is going to be executed. Okay, so essentially this is going to be the SQL statement that is going to be executed here. Okay, so my SQL query runs or executes this SQL statement. Okay, and usually when we put in the ID, say, of 1, okay, this is the query that is constructed. Select first name, last name from users, where user ID equals to 1. So it does essentially what it says here. It selects the first name and the last name from a table called users. That means it's a table of users, okay, where the user ID is 1. This is a perfectly logical syntax for SQL, and obviously the execution is fine. But if we substitute our ID with this code here, okay, what happens is this. The statement now becomes select first name, last name from users where user ID equals to this blank string here. And then there's like an open code here that is unclosed. Okay, so this becomes a malformed SQL statement that later gets executed here. Okay, that leads to this error that you guys saw just now. Okay, so essentially, right, how can we be nasty? Okay, so say if I want to view everyone's username and passwords, this is the statement that I can craft. Okay, it's okay if you might not, you will need some SQL background in order for you to know what statements to craft. Okay, but essentially this is what I can use. Okay, select first name, comma, the parts in blue are the parts that I inject. Okay, so select first name, last name from users where user ID equals to an empty string, union, select user and password from users where 1 equals to 1. So essentially what does this do? This first part, right, it would not match anything because there are no user IDs with empty string that matches an empty string. And then you union that set of results with this other set here, this second set here. Select user, password from users where 1 equals to 1. 1 always equals to 1, right? So essentially what you are trying to do is to select all the usernames and passwords from the user table. And then you union it with the first set of results, which is empty. Okay, and something nice happens. Okay, let me do this on the website itself. Okay, voila. So do you see what happened here? Okay, so essentially the first okay, so this first part of the statement returns nothing, and then we union it with all the usernames and passwords from the users table, and 1 equals to 1 is always true. So we are essentially pulling all the username, all the user credentials from the database. Okay, and as you can see, this first column here is actually, this first row here is actually the username. The second column, the second row is the password, and that's the case for every user that you see here. Okay, so essentially we have turned a text box into something that we can exploit, okay, and input through a concept, an idea called fuzzing, okay. So yeah, this is essentially what is SQL injection. But before that, let's talk about the idea of storing passwords. Okay, so as you see here, right, these are the passwords that we see. But do you think they are the actual passwords of the users? No, right? So what are they? Hashes, right? So yeah, correct. These are hashes, and can anybody guess what password Smithy is using? From these hashes, can anybody guess what password Smithy is using? Sorry?
Password.
How do you know it?
Just do the Google search, you know that.
Exactly. So yeah, you just need to Google search the hash, and yeah, there are a lot of websites which will help you to map the plain text according to their rainbow tables. Okay. So
by the way, right, let me go back to the DBWA.
right.
Did anyone put in the GIA.com thing? Because I think right now, right, what you're seeing is an actual example of an attack. because we didn't put it in. And what I think is it was trying to scan the systems, and it found the port that we have open that creates accounts on the thing, and that's why you see that happening over there. So it's interesting. Like right now, you see something that is real, and yeah,
This one over here.
yeah, that wasn't done by us.
That's probably why our script crashed.
Yes. So yes, learning process.
Your vulnerability machine is getting attacked on the fly.
Yeah.
So like don't expect your machine to not get attacked, because any IP address on the internet will get attacked all the time. My servers get attacked all the time, and since this one is vulnerable, it's probably running some malware by now.
Yep.
It's been running for about 3 days, and now you start seeing these kind of things.
But it's okay. It's a machine that we don't need.
Yeah, we're gonna destroy it later on anyway.
So yeah, that's something cool. So he's right. Your friend here is right. The passwords are stored as MD5 hashes, and you can just reverse the hashes by doing a Google search for very common passwords. Okay, so what's the benefit of storing passwords as their hashes? Okay, firstly, it prevents passwords from being stored in plain text, so you don't actually see what the password of admin or Gordon B is. Okay, but you see this hash here. Okay, however, the bad thing is MD5 is actually very weak. So a few years back, somebody actually managed to find techniques to find collisions in MD5 at a very fast rate. So MD5 is not very secure anymore. Okay, so another thing, can anybody actually tell which users are using the same password? I think it's pretty obvious because I highlighted both of them. So essentially, both Smithy and you can see the same hashes for both Smithy and admin. Okay, so they are actually using the same passwords. But okay, never mind. Yeah, let's just assume that they are using the same passwords. But hashes, there is a possibility for them to collide. So, but we can ignore that for the time being. Okay, so what can you do as a web developer? You can use stronger hashes like SHA-256, for example. And if possible, just delegate this task of storing passwords to a library or a framework. Okay, I'm pretty sure that there are already existing built-in functionalities in the libraries or frameworks that you are using. Okay, on top of that, add salt on top of your hashes, which is yummy, to prevent identical hashes from being spotted easily. So for example, right, so instead of every password being broken down, being hashed into only one other thing, okay, now each password, for example, password, okay, is a combination of the hash and the salt. Okay, so when you receive a password, you actually construct your you actually match it against both the password hash and the salt. Okay, so in this case, even if you use the same password, for example, let's say user 1 and user 2 are both using the same passwords, okay, but they are using different salts. So in the end, their hashes would also be different. Okay, so in the ultimately what you're doing is your hash function, instead of taking only one input, you're taking in two inputs, both the salt and the hashes, okay, to find a particular match of a password. Okay, so the combination of the two will tell you that a password is correct. Sorry? Oh, it's also randomly generated.
So it is randomly generated based on which user is logging in.
It's just randomly generated. It doesn't
so,
have to be based
so
on the
as
user.
when you create a user, right, we have the password, you would generate a random string. Okay, you take the random string, you put it in front of the password, and then you hash that entire thing. And what you store in the database is you store the hash and the salt.
Which is a randomly generated.
Yes. So when you want to authenticate it again, you would get the password from the user, take the hash from the database, sorry, the salt from the database, put it in front of the password that you got from the user, hash it and check it against the hash in the database. Yeah.
Yep. Okay, so essentially you are injecting another parameter into your hash function so that it doesn't appear as a regular. Okay, so going back to SQL injection, what can you do? Okay, so the most recommended way is to use prepared statements if you must construct raw SQL statements. For example, like this PHP code over here. Okay, so you can first prepare the statement here, select first name, last name from users where user ID equals to something. You can ignore this part. So this becomes a variable that will be prepared later. Okay, so you bind later on, you actually bind the parameter, the user's input, okay, into this variable here. So you're doing a safe way of substituting the user input into this statement here. Then after that, you execute the SQL statement. Okay, so by using prepared, if you need to use raw SQL statements, okay, you should use prepared statements instead. Okay, otherwise you can simply use the models provided by your ORM. For example, like Active Record for Ruby on Rails, or Doctrine for Symfony, and Django has their own ORM. Okay, so you just interact with the database via the models. So you don't have to construct your own SQL statements. Okay, so is SQL injection the only form of code injection around? Obviously not. Okay, so if you go to the other page, command injection. Okay, this one here. Okay, so you see that you actually get an interface to ping a device. Okay, and this is the normal usage. You type in an IP address and it will ping the address for you. Okay, so can you roughly guess what is happening behind the scenes when you do that? Okay, well, because I've had some experience using the ping application on different OSs. So anyway, this looks quite generic. This is actually an execution of the ping application on most OSs. Okay, so essentially what the computer is doing, or the web server is doing, is executing this command here, ping 127.0.0.1, or whatever IP address that you feed in. Okay, and it basically returns you the output from the execution of that command. Okay, so in just I need to introduce this idea here, that we can actually separate commands on a single line in shell using semicolon. Okay, so for example, if I want to execute two commands, echo hi and echo there, I can actually type echo hi semicolon echo there. Okay, so this gets executed as two separate commands. Okay, so if the website is indeed executing the ping command in shell, okay, we should be able to append more commands at the back using the semicolon, right? So for example, what we can try is something like this: ping 127.0.0.1 semicolon pwd. So this will be the results from the first command, and this would be the results from the second command. Pwd is a present working directory, so it tells you which directory you are currently in. Okay, so if this were indeed the case, if the web server was indeed executing our input in a manner like this, okay, then we should be able to do exactly like this, something like this. Okay, and if we try that out, you try something like that. Okay, I just terminate the first ping command, and then I type pwd ls, for example. Okay, you can see that it actually works. So the back end is exactly as what we thought it is. Okay, it is simply appending your input to the ping command and executing it in shell. Okay, so just now what I typed in was okay. So at the back end, they are appending whatever you type to this ping word here, this ping command here. So just now what I typed was I terminated the first command immediately. Okay, I typed pwd, which is the first command that returns this output here. It tells you this is the current directory that you are in. And then I did an ls, which is a listing of the current directory that you are in. Okay, so from this you can actually see this is the directory that we are in the web server, and these are the files that who created it? These are the files that are in this directory. Okay. Okay, so another thing that you can do, obviously, you can do a lot of bad things using this simple command injection method that I just described. For example, you can terminate the first command and then you cat. That means you output the contents of the file of for example, of our configuration PHP file here. Okay, then you can see things like sensitive passwords and so on. Okay, so these are some of the malicious things that you can do with command injection. But if you must, okay, just now what we showed you was not a very common feature of websites. But if you must have such a service, what can you do? Okay, you should perform input validation. For example, like just now, should check that the input given is a valid IP address. Okay, so you must make sure that it strictly is an IP address and nothing else. Okay, otherwise you can also check against a whitelist, but usually not a blacklist. Why? Sorry? False positives. Yes, but also blacklists are difficult to maintain. Okay, so you may have a lot of malicious inputs that would actually map to the same results. Okay, that can be used to perform the same set of actions. So a blacklist wouldn't be enough because there are essentially many things that an attacker can inject in order to achieve a malicious outcome. Okay, so instead use a whitelist and also perform some input validation. Okay, so the next part that I will talk about is cross-site requests. The next vulnerability which I will talk about is cross-site request forgery, okay, short for CSRF. So for this, you can go to the CSRF website, okay, which is over here, and you can try changing your password. Oh, this is, by the way, this is the reason why I wanted everyone to use separate accounts, but it's fine. Okay, so anyway, if you try changing your password, okay, you will notice something strange in the URL. Okay, the URL actually displays something like this. So this is the website, and then it says password new equals to my new password, and password confirmation equals to also my new password, and change equals to change. So what is the danger in doing something like this? Okay, you can see that your passwords, your new passwords are all passed in plain text in the URL, right? So what's so dangerous about this? What if somebody lured you to click on such a link and the results aren't so obvious? Okay, so your password could have been changed without your consent, but you say it won't happen. Okay, after all, who makes applications that are so vulnerable? Do you use uTorrent? Okay, in the past, not very long ago, uTorrent used to have such a vulnerability. Okay, and many other websites as well, but I highlight uTorrent because many of us use it. So in the past, right, for the old version of uTorrent, you can actually force someone to download a file by pointing them to a URL like this. Okay, so you just point to a backdoor of yours, and they'll be off downloading your backdoor. You can also force them to change their credentials by getting them to click on or enter links such as this. Okay, so how you get them to go to these links, it's up to your imagination, or we'll have some ideas later on, which Jeremy will talk about. Okay, so now you see the danger in such cross-site request forgeries, right? So how do we tackle this? Okay, can you all use your edit these cookies plugin to change the value of the security value of this website from low to high? Okay, so you just do it like this. On the top right hand corner, you find the cookie, you click on it, change the value from low to high, and then click the tick. So that's how easy you can edit your cookies with edit this cookie. Okay, so now when you change your password, what do you see? For example, I change it back to password. Wait, I need to refresh. Okay, password is changed. And you might have noticed something new in the URL. Okay, this thing here. User token equals to something. Okay, and what's that? So that's a CSRF token. So essentially what you want to make sure is the user actually landed on that form and executed the request from there. Okay, so what you can do is put a token, a uniquely generated token in the form, and when the user submits the form, he or she must submit that token along with the request. Okay, so that's how you can authenticate the origin of the request by ensuring that the user submits the correct token. Okay, and since the attacker does not have access to the token, he cannot craft a link that would contain this token here that he will need in order to get you to change your password. Okay, because he does not know beforehand what that token, that uniquely generated token is going to be. Okay, so he will not be able to create a link that will be able to get you into doing something. Okay, so for example, this CSRF token is already enabled on most frameworks like ROR, Django, and Symfony. Okay, and what you have to do, it's very important, is not to disable it. Okay, so you can see, for example, here, this is a Symfony application, and this is, for example, the CSRF token that is automatically generated by the web server when you access the web page. Yep. Okay, so with that, I'll hand the time to.
Yeah, you guys want a break? Because it's actually over time.
Yeah.
We take 5 minutes break and I'll finish up the common vulnerability. Then we can break until 6. Yeah. Yeah, sure. So we take like 5 minutes break.
Should we reconvene at 6?
No?
You still have quite a lot to cover, right?
There's a couple more slides. Only about, I think about 3 more minutes of it. Yeah, then I can finish it up, and the 6 o'clock we can do actual scripting.
Yeah.
Yeah.
So take a break.
Maybe we can take a break for 5 minutes for those who want to.
While we're at it, I need to get a poll for who's going to eat here for dinner. Again, we're going to order whatever you guys want to eat. Yeah, I think they want it a little early so they can also make it a little earlier. So we'll order the food at 5:30. And then we'll have them run 6 o'clock. And this day over there. 1, 2, 3, 4, 5, 6, 7, 8. And then we had a couple people walk up, so we have about 10 people. What do you guys want? Same option as last time. Subway, Domino's, these types. You guys had Domino's last time, right? What do you think of it? Or you want to have it again? Everything is fine.
I was wondering why the script keeps.
Subway.
I was wondering why the script keeps.
I think it's probably like you crash.
Doing hot take.
No, it's always been happening. It happens.
Subway or Pizza Hut? You're the timer. Yeah. One for each.
Oh,
Subway.
Subway.
Yeah.
Okay, Subway.
Yeah, like the product.
So, yeah, you can come to me with your sub preference and then I'll order you a sub. Okay, I've already ordered drinks, canned drinks in the car, so just let me know what you want.
There's some water.
Half full.
No, so after you drink half. Yeah.
Do you have any questions regarding the what we talked about just now? Actually, the ones that we showed you are very superficial attacks. Yeah, but there are usually already mechanisms to prevent the simplest attacks that we have showed you just now, and there are even nicer ways to get around it. But because most of you are not very familiar with them yet, so today we are just introducing the surface level one. Yes, it's you literally can change the page source code. Correct. So you end up having access to the data in ways that the developers did not intend for you.
Like, is there any specific kind of platform you guys are using? You guys are interested in? I'm very familiar with Django, so if any questions, right, you can ask. So Django is pretty nice because it has a lot of inbuilt security protections. It's quite impossible to do external injection if you use the ORM correctly. There are ways, but they're quite impractical. The access protection in Django is really nice. The context Django is in always escapes it by default. Yeah, so unless you really disable everything, Django should be pretty safe. So we should really look out for more like business logic stuff.
Can you give an example of some business logic?
We'll talk about it in the exotic.
Yeah.
Okay.
It's actually like
We are actually worried about disclosing some of them. Because,
so maybe like during later on we'll turn off the stream and then we'll show something real.
Yeah.
Because they're great. Yeah.
Sure, yeah, no problem. You turn off the screen when it goes through something sensitive.
Yeah.
Camillus, when he did the same thing, he also showed an injection into, I told you, I had a session in IBLE where he became me using his credentials. So, he didn't want that coded wrong.
IBLE, I'm trying to integrate it with my system, but I find out that they do not have the scope for the IBLE whereby I can actually access all the data that users as a user. So, I would like to know how to
Okay, everyone who's staying for dinner, go to the Subway site, tell me what sub you want. Yeah. Just come by and let me know.
see that the IBLE is usually right ourselves.
You can just tell me how this is a live
And
you know what you want?
the IBLE website will be 6-inch session to type up there. So we are using that to create certain section but that particular document is not like Facebook actually takes certain techniques combination and then read certain information. So I'm not sure how to secure this part of the
Are you affiliated with
Yes, I am using another set of checks and extends the idea.
Okay.
So I usually will capture information about IBLE in my own data. But it's not how that idea improvement. I got to show how should I store it or I shouldn't store it at all.
So
There's one thing that ask them to pass their token.
But then that exposes a lot of like thank you, don't you have like always have the users having right. Someone just sits in the middle and then they can capture that. Sometimes you can also they're always big around that.
So I should store the token. But even with isn't it like fear of privacy, because once I have the token in a piece of database, I can actually. What do you mean by I want to fetch some info.
Before like proper solution. We have to be that
Yeah, no, actually it covers only some so the user will see something like
Thank you.
thanks so much for making that. If I can download my server, then I can the other way is that I store the token in my database, but only if that is validated in the environment. When I store it in the database, store this information. I'm not sure whether it breaks down two policy or I find that I still say so it's like as long as I got access to that controller, I copy it down and then it's somewhere else on accelerator.
You know why? Oh wait,
Because I'm accepting any password.
I use that. It's very good. If I'm not wrong, the original authors, I mean, because they are like professional documentation people, so the site is part of the best.
What's holding you guys? Things that are doing like only thing I know is like the
So it's like we only need another set of skills.
Yeah.
We need to do actual.
If you join Grey Hats, we would learn more of these kinds of things.
Of course. But mostly you have to learn these kind of things yourself. Yeah. The benefit of joining us is having like-minded people together to talk about such things and to ask and to do such things together, play such things together.
Yeah.
But you still have to do a lot of learning yourself. Actually, even in developing, it's mostly like that.
You can't expect people to just spoon feed you with everything. Yeah.
This set of program
It's just one size, right?
laptop is actually, and
Anyone else who has
how
more?
how so links between them, something like that.
You guys order in the back?
So like, is this the person using stuff?
Yeah.
And yeah, it works and works.
Yeah.
So like in this case,
Okay, and come here. One is essential.
But it's still the same thing.
yes, but actually Django is slightly different from traditional, like
Both are edgy.
Maybe it's
yes.
That's good. In this sense, in the
Yeah.
Yeah, that's a real one.
Yeah, so, yeah. You bring it back up? We still need it. We don't need that. It's like,
Yeah, we don't need. We're just doing it.
so is everyone back?
We want to moderate stuff.
Have you done it yet?
Yeah, I ordered it.
What do you get?
Chicken teriyaki.
Really,
You get a vegetarian burger for that.
One side. Anyone else for dinner? 5:30? No, by 1:25? Listen to shows. Roasted chicken breast wrap. Yeah. With mayo and bacon. All right?
I'm thinking why the HTTP, why the URL would
I think it just crashed. Yeah.
actually it didn't crash everyone. But if it didn't crash, then why isn't it? That's true. I just now I realized it didn't crash, okay?
Okay, so if everyone's back, I'll just finish up this part and you can continue with your work. Yeah. Okay, so
Yeah.
Okay, so now open redirects. You've all seen those little web pages where once you do something and then you go to another page and it says, okay, you're redirected to the main page, for example. So it seems really harmless, right? But okay, can you think of a way how you exploit that? How can that be exploitable? Just the act of redirecting you from one thing to another thing. There's a clue just now already. A little clue. Okay, so let me just tell you. Open redirect is a vulnerability where an attacker controls where the victim lands from a redirection service. So this means that while a legitimate use of the redirect might bring the user from google.com/login to google.com after logging in, if you can control where it lands, you can redirect the user to attacker.com, for example, and then you can do further exploitation. So now, this doesn't seem like a big deal. So he just visits your site. So what? But imagine if you were given the option to click on the following link to proceed, right? Would you click on it? Does it look suspicious to you at all? Yeah, something like if you just get email saying that, okay, you need to check this out. You just look at that. It doesn't look very suspicious. It's from Google, right? Nothing wrong. So this is why it's suspicious, because if you have open redirect and redirects you to like the google.com/o, you could get maybe a fake Google web page and it asks you to log in. And you log in with your Google credentials. Now you've lost your account. So
you can also actually do something like just now this one here. For example, you redirect the person to this malicious URL that changes his password or so on.
Yes.
Yeah.
So this is one way you can chain two different types of attacks together to get a very, very strong primitive. So I have actually a site where you can play around this. You can just visit the site. I should open this. Okay. So this is the site, and basically I just have the source code there as just to show you what it is. So what it does is it takes a parameter redirect. Okay. So if you give it a redirect URL, it actually sets a header where you can give it any location to go to. So if I'm going to go to maybe, escape. Okay, so I'll have URL, and then I'll maybe go to Google. And it sends me to Google. So imagine if you know someone who trusts this site, maybe this webspawning.com, and you send it to him and say, hey, check out this challenge. And then you send him to a site where you have like you can change his password from. And this is a way you can exploit that. So let's say I have like an example site. Yeah, you can. I think you can. Okay, let me try this. So bad.com/change password. So then you change your password through this. Okay, now let's try this. It sends you to bad.com. Oh. Okay, so let me try something different. I can actually URL encode it.
JavaScript.
Interesting.
Refresh.
Okay, so now it doesn't look so
suspicious.
Yes. So if you give it this thing, let's see if it works. Yeah, it's internet.com.
So earlier on, y'all were able to, y'all decided that the Google redirect was suspicious because y'all could see the URL in very clearly, right? So you can use, for example, some encoding schemes like this to hide the final destination from the user.
Yeah. I mean, we've all seen the really long URLs that we don't really bother looking at, right? For example, if you go to even IVL, it sends you so many nonsense URLs. Okay. So now, how do we stop this very simple vulnerability? Firstly, don't accept any untrusted input from the user. If the user can control anything on your server with that kind of consequence, then it's all game over really. So if you do not have a choice and you have to let the user specify where to land, for example, this appears in the GitHub API, because they actually have a hook where you can do integration with apps. And what they actually do is once you ask for permission, it redirects you back to the site itself. But what it does in this case is it has a sanity check. It has a whitelist saying that it can only return you to the same domain where you came from. So you want to have some kind of constraints that prevent you from unrestricted redirects. And if you, I think the best way is just to have a mapping between maybe an index and a list of two sites. So you always know exactly where the user will land. And if, yeah, they can't control anything from this index. Okay, so directory traversal. Imagine your web application needed to handle like serving files from different locations that they are dynamic. So it's not practical for you to create like an if statement saying that if the URL is maybe the parameter is give me file 1, then I want to serve this file. If you give me file 2, I'm going to serve this file. And it's not practical to create hundreds of if statements or anything to say that. So you have to craft that request dynamically. You have to look for the files dynamically on the file system. Maybe it's named like file1.png, file2.png, file3.png, and so on. So if the user wants to find, let's say, I want file 4, you don't have a specific case to handle that. So you craft that file 4.png dynamically. Now, so if let's say the user wants to request it, and if they exist, it'll look something like this. It'll look something like this app. So this is an example Bravo application. You can try and break it. So can I just ask, how do you think we can exploit this particular script? Let's just focus your attention on the key block here. This area. So okay, let me just give you a little hint. You have a file parameter it takes in. It checks whether the file parameter exists, and then it gets the contents of the file dynamically. It looks in the nums directory and appends it to the whatever you get it to. So, how do you think we can make use of this to do that thing? Okay, so how do you change the directory? Okay, so let's say the normal execution will be like this. Okay, it's going to show this number 1, it's going to show number 2, number 3, and notice this part here. Notice that little thing changes over there. Okay, so let's say I'm just going to change the file. Do you think it's a 6? I think it's a 6. So yeah, it's a 6. So now say you want to change the directory. How will you suggest changing the directory from this what we have here? But that's the right idea, changing the directory. Okay, so in Windows, right, when you do a dot, it goes up on the directory, correct? So now that's the way you can change the directory. You can go up all the way. Okay, let's say I will go up. That's annoying. Like that. Obviously, there's no file yet. I don't know what file exists currently. I said maybe basic.php. Yeah. Wait, something happened. Like something weird happened. Because you know that you're in the num directory, correct? And now it's going back up 1. And this is where the basic.php lies in. And we've managed to do something weird and print out something that happened there. So for those who are familiar with Linux, you can actually test for this stuff by looking for the /etc/pass.ub file. It's basically, let me just show you, and it's quite obvious why I want to look for that. So I'll just do a lot of this so that I'll go all the way down to the root directory, and I will do /etc/pass.wd, and suddenly I have the name of all the users. Yep. No, too much, done too much bad things. Let's cut this out. HTML I1. Yeah. What? Go to HTML1. Press this, go to
No, that one.
It is. What?
No, it's not the VG input, right? Yeah, I think it's just when you press it, it takes sometimes to switch to some buffer. So it's something all of your command inside.
Let's check the stream. Okay. Okay, so since we interrupted, you can actually see things like this. And this is basically something that is important because they only can read stuff right now. But what kind of files do you think that you want to look at? You look at users files, you look at sensitive files like what's the one that
Shadow.
No, we can't read shadow. So certain things like shadow, right? Basically the pass.wd file is more readable because certain applications need to know what users are on the system. So this is something that is publicly available to all users on the system. But if you wanted to look at passwords, it's in shadow, and it won't show you anything because the shadow file is protected and only readable by root. Okay, so oh no. What's that database configuration? Right. Okay, there are certain things also that you can try and read. If I'm not wrong, you can read self.environ. On certain systems, self.environ, if you don't protect it, I apparently protected it too much. You can actually dump the list of environment variables that are available to the process. So in certain applications, for example, Ruby, you can make use of something like this to dump out whatever content you want and have it executed, because what happens is in this case, it just replaces the script there with whatever is in the file. So if you have something like pop.environ and you have a password in it, but in certain cases you don't store password in files, you store it in the environment variables as a security measure sometimes. And this will reveal it. Yeah. So that is directory traversal. What is this? Not HG. I think it's refresh. Yeah, slightly more crisp. Okay, so this was the source code. Yeah. Okay, so it looks fine at the first glance, right, like just now. But this file is equal to this file if you go up on directory. So there are actually many real life examples. Actually, I can show you one. Let me mute the stream. So now how do we fix a directory traversal attack? We again consider using mappings between indexes and predefined locations, predefined files. And if you don't want to use that, you actually can use a change root jail, which gives you an isolated environment for you to look for files in. So imagine if you had a really attacker-friendly environment and you wanted to play around, but you still don't want them to attack your main system. You can create like a little matrix for them to get lost in. Yeah. Well, and also something else you can do is you can, if you want to restrict it for just a predefined path, you can get the absolute path for these files. You just resolve absolute paths. It's called normalization, and then you check that these absolute paths have the prefix of your predefined approved folders. Yeah. So this makes it certain that it's within this root or within this set of directories. So the next thing is a local file input. Yes. Okay, so like imagine, imagine, let's get imagine if you did this, right, and we just normalize it, it will be like this. So this is like the absolute path. And let's say you need to allow stuff from here, maybe. So when you do this, right, it doesn't have this prefix. But if you do something like this, this will actually resolve back to here. And you can let it through, even though it's all messed up. Yeah. So this is what I mean by validating the prefix. Yeah.
Do you all know that there's a function that you can use to normalize file paths on the system? So that means essentially you convert you standardize the way in which a file path is represented. So essentially every file on the file system only has one normalized file path. So after you take in the user's input, okay, so it can be any number of dots or something, and then you normalize that. Then you check the prefix of that path, which is supposed to be a standardized one. So instead of checking all the different variants, you just check the standardized one.
Yeah. Okay, so the second last thing to talk about is a local file inclusion. Okay, so you know that having a modularized application is a good idea. You would have maybe like some functionality in this folder and some file, some source file, you have some functionality in another file, and you often import or include sources. But however, when you give the user the power to choose what to include or import, then you run into a big problem. Okay, so in PHP, this arises a lot because sometimes you build stuff that has a dynamic kind of web page where you would include different source files that have different behaviors. I'll show you in a bit. And in fact, it can also happen to any other kind of framework. Django included, Ruby on Rails included. In fact, I actually wrote about one Ruby on Rails rendering vulnerability. And what it did is, in the template, it lets you choose what template to run or to include. And from there, you can specify your own templates from somewhere, and then you can run arbitrary code. Yeah. So when you can think of inclusion of a file as simply as if you take the code from that file and you copy paste it into the code that's coming, the script that's coming executing. So it's really really serious because some people think it's just a read-only thing. It's just an information leakage problem, but it can be escalated into an arbitrary code execution problem, and that means game over for your server. Yeah. So the factor code looks remarkably similar to directory traversal, and in fact, we're going to use the same kind of concept. Okay, so in this app, right, what it does, if you click on this, it shows you a different bio information for different characters. So points to those who can recognize the names. Yeah. Okay, so if you see the source code, this is the source code. And what it does is very simple. You get a page, and if it's set, you change directory to something called pages. You just go change directory to pages, and then you include this file, the file that you chose here, and you append PHP to it. So you're actually including a PHP file, the source file, and you show the bio input here. So if you include main, right, what happens is it's going to craft main.php, and it's going to include main.php in the directory pages. Yeah. So it's very simple. Now you know that about directory traversal, can you think of a way to exploit it? Just throw any ideas there. Yeah, maybe let me just give you a go. We don't have an option for the plague right here, but we want to know what his bio is. So let's try to get his bio. So anyone have any suggestions on what we can do? Yeah, give me something to try. Okay. Okay, so how do you want me to spell it? Like the plague? Like that? So I mean, it doesn't work because there's now if you think about it, right? There's no such file called plague.php in there. So you just follow the. Let's say make a guess, right, and follow the same thing, and say okay, there's bio there. So okay, this is cool and everything, right? But let's say we know that the plague is hiding a secret. So now it's just gonna display it, but what happens if you want to figure out what the secret is? And it's inside the source code. You can't access the source code just by including it like that. So it's being excluded. Just remember, everything that is included, right, is considered being copy-pasted in the correct excluding context. So if you had, like maybe the secret is a variable, and you want to find out what the variable, it's not going to show up. But there is a trick that I like to use, something called PHP filters. So the thing about PHP, right, is that it has something called a filter, which lets you treat it as a resource, and it lets you chain different transformations together. So in this case, right, what this filter does is it takes the resource, it applies the base64 encoding to it, and returns the result. So I'm just going to show you if I try this code, right? This. And place it here. It's going to take the fake.php, base64 encode it, and return the result. And if you can see, there's some garbage there, right? So if you can recognize that, it's actually base64. So let's copy it and figure out what the contents are. Okay, so you could use something like online, or I'm just going to use the terminal. Base64, you can see. Okay, now this is the source code of the PHP script. Yeah. So in this method, right, you basically gotten the script source code through a local file inclusion vulnerability. Yeah, and so you can see the secret there. Now, most of the time, right, you don't have access to the source code for web applications online. So this is one way to get more information about our application and look at what vulnerabilities it has. Once you found this initial vulnerability, and you can turn it into a complete framework code execution situation once you find the right primitive. So right now you have a read primitive. If you have a write primitive, you can actually write something to a file. You read that file and you can execute your own code. And that's usually the path we're using Go. So again, how do you fix this? Mapping, of course. You map index, you map predefined constants to predefined whitelisted files. And you should never allow any user input to be present in the argument to include, or any user input that is preformed. And of course, once the attacker can control the include, right, it's game over. There's so many ways for you to gain local file inclusion. You can read the process environment. In some cases, there's Perl CGI actually used to be able to. They used to use the environment to pass parameters. For example, the request headers, right, were put into the environment variables as one line each. So imagine you can read from that environment variable, and you have some Perl script or PHP script, and you can execute code execution in use that way, just by crafting a custom HTTP request header. So yeah, whitelist your source files if you absolutely must have the parameter sent by the client. Yep. Okay, so the last thing is there are many ways to make a system insecure, but if you aren't careful, you can introduce bugs. So this is not really something that's part of the language. So this is many people are tempted to roll their own application systems. It's make people easier to use, and oftentimes they fail, and so they fail really badly. So one such way is to do it is by not making use of a secure means of maintaining persistent data for the user. Now let's take an example here. Okay, so let's show the source again. Okay, so what this does is now it's a little more complicated. It takes there are two things. One is if there's a post request, which means you submitted a form, and the other case is you are just making a normal GET request. So if there is a cookie present in user, it will just echo the username and the user. If there's a cookie named admin, then you are admin. So let's see if this part here, the password here and the user. So let's just log in, and it sets the cookie to orbital user eventually, and it sets the admin to 0. So in this case, there's no way for you to become admin legitimately. Let me show you. So there's success here. And let me just take away the source code so that you don't mess it up. Okay, so now you can see there's a. Okay, you can see there is a username here, orbital user, and there is no message saying that you are admin. Okay, now, how do we get admin? Can you think of a way? Okay, so let's change the cookie, and what do we use? Okay, so we have our trustee edit this cookie, and we see that there are actually indeed 2 cookies that are available. And this admin value is 0, so let's just change it to 1. Save it and reload this, and now you're admin. So we think this is kind of a stupid thing to do. It doesn't happen in real life, right? But it does all the time. It's not so clear cut as this sometimes. It can be a user string, and it might be something like, it could be a JSON string that's encoded, and you decode that and realize there's an admin field in there. So once you change it to true, and then it gives you access to everything. So you do see that in real life, and don't be surprised this thing can happen. So make sure don't do this kind of things in your own apps. Always show you. Always analyze the level of trust you place in your users. Don't trust your users with, don't trust the integrity of the data that the user sent you, unless you employ some cryptographic primitives and all that. prefer storing the data on the server side because if you allow your user to tamper with it, I can bet you they will. And only carry the session ID. That's what session is for. It's for you to maintain session-based variables on the server side. Yeah. So that's it for the first hour. Okay, 2 hours.
First 2 hours.
Yeah. We can come back at 6, and then we'll carry on with maybe a bit more hardcore stuff. Yeah. So thanks for sitting through.
So just like the game development group who gave the last mission control, these are your fellow members in SOC who are giving the tutorial. So I hope if you're interested in security or you're taking information security as your major, you should definitely work with this group. Just a reminder about Things Orbital. Probably you all completed your milestone 1 yesterday, hopefully. Yes. Okay. And right now we have a bug in Skylab, so we cannot actually